Today's lesson is section 1.1, solving equations, day 2, so kind of a continuation of stuff that we talked about yesterday. Very first thing, we're just solving this example for h, and what's weird about this example is that there aren't that many letters in it, it's just a bunch of different variables. And yeah, you might recognize this formula from geometry, 2b plus ph, that's the surface area of a prism, but nobody cares. I mean, we do care. But all we're going to do here is just try and get h by itself. So read the directions carefully, and that tells you what variable you want to get by itself. So in this case, what I'm going to do first is subtract the 2b over to the other side, because I'm trying to isolate h. So I'm moving stuff out of the way to get h by itself. And s and 2b are not like terms, so all I'm going to write is s minus 2b. And then I have ph. And so just because these are variables and not numbers, we can still solve this the same exact way. Now I just need to get h by itself. So in order to do that, I need to divide both sides by p. And make sure you divide everything by p on the left. So the answer for h, and this will be similar to what you'll type into Math Excel, is you'll do s minus 2b over p. And yeah, that looks a little bit weird because there's no like terms, there's nothing we can combine, there's no numbers to simplify, so we're finished. But very basic problem to start with. Same thing we're going to do here for number 2. We're solving for big B, and yes, there is a big B and a little b. And so this formula is actually the area formula for a trapezoid, if you remember that from geometry. But again, nobody cares, except me. I feel like I'm the only one that cares. What we're going to do here is, one easy thing that I could do just to cancel my 1/2 is multiply everything by 2. And so that's what's going to cancel the 1/2 on the right. So that makes it a little bit easier. So now what I have is 2a equals big B plus little b times h. Now there's actually two things that you could do now. A lot of you are probably thinking, let's distribute the h, and that's fine. What I would like to do first, since we're trying to get the big B all by itself, why don't we cancel the h, just like we canceled the 2, or the 1/2. What I'm going to do here is divide both sides by h. That will cancel that, and then I didn't have to distribute. Okay, so now what I have is 2a over h equals big B plus little b. And all I have to do, what I'm solving for, remember, is big B, so I just need to minus the b over. So when I do that, just keep in mind and be careful that we don't have like terms here. So my big B is going to be equal to 2a over h minus b. And it's minus little b. So make sure you don't put that all over the fraction, because the only thing that is the fraction is the 2a over h. So make sure that the b is off to its own, especially if you're typing that answer into Math Excel. And let me show you what that would have looked like, just in case you were curious. What if we would have distributed here? So I'm going to kind of recopy what we had here before I divided by h, because there are multiple ways to do these problems. So maybe you were thinking 2a equals big B plus little b times h. What if you were thinking distribute? So that's fine. We have big B times h plus little b times h. And I'm trying to get big B by itself. So right now I'm going to subtract the little b times h. And that gives me 2a minus bh equals big B times h. And again, I'm just trying to get big B by itself. So I can divide both sides by h, divide by h, divide by h. And I get 2a over h minus b equals big B, which is the same thing we got here. So either way you do these problems, there are a lot of times multiple ways to solve it. But I wanted to show you both ways on that one, because there are multiple ways to get the correct answer. So for the third couple examples, these are a little bit harder. I did write some steps over there in the box that I'll refer to in just a second, but I'm going to dive right into the first example, and then I'll talk about what those steps mean. Is because what you're hopefully noticing right now is that we have multiple x's in this example, and it's telling us to solve for x. And so you might be thinking to yourself, well, am I supposed to solve for this x or for this x? So right now, first thing that I know that I can do is let's just distribute the 5 and kind of see what this looks like. We have ax minus 2b equals 5x plus 5a. Okay? Again, we have an x here and we have an x here. Which one are we trying to solve for? We're trying to get just one x all by itself. So there are some tricks to doing these, and these are kind of hard algebra problems. What I'm going to do, and what the goal is to group the x terms together. See how this is ax and this is 5x? I want those on the same side of the equation. And I want everything else on the other side of the equation. So what I'm going to do is get my x's together. So get x terms together. That's what I'm going to do now. So you could move this term over to this side, or you could move the 5x over to this side. So I'm going to keep my x terms on the left. It doesn't matter which way, you get the same answer. But I'm going to have my ax here, and I'm going to subtract the 5x. So what I did is I moved this 5x term over, which is why it became negative. And on the right-hand side, I still have the 5a, and then I need to move this 2b over to this side. So that becomes a plus 2b when you move it over. So right now, what I've done is I've found my two terms that have an x in it, and that's what I'm trying to solve for. And I've gotten those on the same side of the equation, and I've moved everything else over to the other side. And so now, here's the trick, you guys. We're trying to get x by itself. Keep that in mind. And look how cool this is. Now you can factor out the x, which is awesome. And that's why you got to get your x's together on one side and everything else on the other so that you can factor it out. So now I still just have 5a plus 2b over here. And now you know that all I have to do in order to get x by itself is divide by that factor of a minus 5. So I have x equals 5a plus 2b over a minus 5. Done. So it's kind of an algebraic trick. That's supposed to be an a, by the way. It doesn't really look like it. Okay. Is to, let me zoom out so that we can see the steps that I wrote and then kind of go through that. So the first thing we did is we distributed. I distributed my 5 in this example over here. And then combine any like terms that you have, and there weren't any here. So I kind of skipped this combining part. But number 2 is to get x's together on one side. And then you got to get all the other stuff on the other side. And that's what we did here. We grouped our x terms together, and we got everything else on this side so that we could factor out the x. That is the trick. I'm going to put a little star or an arrow next to that one. That's the trick in order to solving stuff that has multiple x's in it. And then all we had to do once we got our x by itself was divide by that factor, and that left us with our answer. Okay, let's look at the second example and kind of keep in mind what those steps are that we wrote in. If you need to pause the video and finish filling in those steps, that's fine. Okay, here again we have multiple x's in our problem. So I think what I'm going to do first is cross multiply in order to get rid of the fractions. So I'm going to multiply this side. X times 1 is just x. And then when I multiply this side, unfortunately, yeah, that means I am going to have to FOIL. So I'm doing a times 2 times ax minus 1. That's going to be, it's going to look a little bit weird, but when I do the first terms, a times ax, that gives me a squared x. And then when I do a times negative 1, I have negative a. And then 2 times ax, and then negative 2. So that's just foiling. That's how I got all that stuff. And again, check quickly, there are no like terms to combine, but I have a bunch of x's. Do you see how here's an x, and here's an x? So I need to get all of those together on one side and leave everything else on the other. So I'm going to move this term over, and I'm going to move this term over. And I'm going to leave the negative a and the negative 2 where they are. Okay, so that's going to look like x minus a squared x minus 2ax equals negative a minus 2. Okay, and now you can see that everything on the left here has an x term in it, so you know what comes next, factor out the x. And be very careful here, when you take an x out of this first term, there's not nothing, remember? When you divide x by x, you're left with 1, so you need that 1 in there. And then when I take x out of negative a squared x, I just have negative a squared. And then when I take x out of negative 2a, I have negative 2a, and that leaves me with negative a minus 2. Okay, so now all I have to do is divide to get x by itself. I have the negative a minus 2 on the top, and that entire quantity of 1 minus a squared minus 2a on the bottom. Alright, and so the last thing that some of you might be thinking is, when do we know that we're finished? Like, what if something factors or cancels here? So I do notice that in the top, I have a GCF of negative 1. Let's just see what happens. When I take out that negative 1, I'm left with positive a and positive 2. Okay. And then I could rearrange these letters so they're in descending order. And then notice that this sign is negative and this sign is negative. So what if I took out a negative from all of those and rewrote it so that they were in descending order? So if I take out negative from negative a squared, I have positive a squared. And I have positive 2a. And then the sign on the 1 is going to change just because I divided everything by a negative 1. So just keep that in mind, that you can kind of look for GCFs and still try and factor and cancel anything. And you do notice that these negative signs can cancel. So another way to write your answer, and I'm going to put or here, would be a plus 2 over a squared plus 2a minus 1. That part doesn't factor. And if it did factor, of course, you would want to factor and cancel whatever you could, but that part doesn't factor anymore. So either of these answers are correct. Sometimes we don't like to have so many negative signs in our answer, but either of those are correct. So if you're checking answers and stuff, you need to be able to identify which answer is correct and whether or not you made a mistake. So both of those are acceptable answers, and you might have had one of two different ways if you were working through that on your own. Okay, so let's see. Let's do this last one. Again, we're just solving for x, and there are multiple x's in our answer. So very first step in our list of steps over there is to FOIL this stuff and then combine any like terms that we have. So when I do 2x times 3y, that gives me 6xy. Be really careful and diligent when you're doing your FOILing. And then see if there are any like terms that we can combine. There are not any like term. Oh, actually there are. Notice that there's an x and there's an 8x here. So we can combine those. And we're going to try and get our x's all on one side. So I'm going to move over this, and yes, something will combine then. I think I'll probably show all that work. So I have x minus 6xy minus 8x on the left, and I still have negative 3y and negative 4 on the right. And yeah, I'm definitely going to combine the x and the negative 8x. That gives me negative 7x minus 6xy. Negative 3y minus 4. And again, here we are with our negative signs. So let me show you another algebraic trick. Notice that every single thing in this entire equation is negative. Well, here's a trick to get rid of all those negative signs. Divide every single thing by negative 1. That's going to give you positive x plus 6xy equals positive 3y and positive 4. Now I've gotten rid of all my minus signs. So these are the same thing, but it's a little bit easier to deal with an equation where it's all positive versus where it's all negative. So if I hadn't done that step of dividing by the negative 1, then I could have taken out the GCFs at the end and canceled them, and I still would have had all positive numbers. But it's a little bit easier to do it right away. Just divide everything by negative 1, change all the signs. And again, you're allowed to do that because we have an equation here. If you do the same thing to one side then the other, then it's still the same equation. Okay, so now from here I've got all my x terms on the left together. You're going to factor out the x, and we have 7 plus 6y and 3y plus 4. So now all we have to do is divide. And I have 3y plus 4 on top, and I have 7 plus 6y on the bottom. And there's our final answer for that one. Again, be careful, we're not canceling the 3y or the 6y because there's no GCFs in either of those, and you can only factor if you take out GCF. So there is not a GCF, there is nothing that factors there. Those are stuck together in those binomials. That's all for today. Thanks for watching, you guys. Have a good night.